Too. Big data is dependent on the basic concept is that you take a big problem and you fragment it into small problems, and then you run those small problems on independent computing nodes. Now, it's kind of like virtualization, but it's the application virtualization by breaking that app up across a large number of nodes. And the biggest issue for the performance of big data is the latency that you get between the compute node and the storage node. So the longer that the compute node has to wait on the storage to respond, the less compute that you actually get from your overall system. Let me give you an example. So if you've got 4 cores in your CPU and 256 threads, if all your threads are waiting on storage, no computing's happening. If you can reduce the latency of your storage by, say, a factor of 10, surely you should be able to do about 10 times more computing. So you actually get a huge amount better performance by reducing latency. Now, the way that that's been done up until now is we've used things like Hadoop and other technologies which ensure that the storage is kept close to the compute nodes. By adding flash storage into big data, we can actually intrinsically drop the latency of the storage and improve the efficiency of the big data. So I think we're going to see more and more flash storage being used in big data applications to really increase the efficiency of those large compute arrays. Storage is growing. I think the last time I looked, it was 43% compound annual growth rate. Now, 43% compound annual growth rate, I wish I got that for my money. I'd be very rich, because I'm quite old. But if you think about this as an enterprise, you've got a petabyte of storage this year, you've got 1.43 petabyte next year, and before you know it, you're into tens and hundreds of petabytes. This is a really big upward curve, and it reaches the point where it becomes unsustainable. So I think that there's a few things that we really need to be thinking about. Back in the old days, when storage was really expensive, people actually used to delete data. We don't delete data anymore. And at 43% compound annual growth rate, there's no question in my mind that we're really going to have to adopt policies and procedures that allow us to delete data that we don't want anymore. And that's something that I think is new thinking, and I predict that it will happen. We will have to delete data because it's unsustainable. And secondly, I think we're going to have to be really looking very carefully at block and file level deduplication. If you store a photograph on Facebook, do you really want to have 7,000 different copies of it scattered across the world? Probably not. You maybe want the most 2, just in case one gets damaged or you lose it, but you don't want lots of them. And I think that is a really important thing. In the same way as camera and audio technology has been using compression and JPEG file formats and so on to reduce the size of very large files, we really need to be looking at data compression on disks as well to deal with this massive growth. Well, I think there are 3. The first one is massive growth in capacity, and I've covered that. We've got massive growth in capacity, and we had a strategy about really leveling off that 43% annual growth rate. The second thing is many applications that have got latency sensitivity. We need to use flash storage judiciously in those kind of environments to give good application performance. And I think the third thing, and this is particularly true for mid-sized businesses, but also for enterprises, is how we integrate on-premises storage with cloud-based storage. And the thing about cloud-based storage is it's particularly things like Amazon's Glacier, which is tape-based. It's long tail, it's designed for archiving and putting stuff out there that you're not going to look at again in a long time, and really quite inexpensive. But how do you actually make that work using your existing business processes? So if someone's looking for a document, how do you find that document that was stored 25 years ago? And how do you actually find the application that allows you to open it? Well, some of you who are listening to this might remember Lotus 123 and WordPerfect. Some of you might not, but there are even older applications than that. If you've got a WordPerfect file today, I think you'd probably struggle to be able to open it. I think you'd be struggling to open a Lotus 123 file as well. What are we going to do with all the file formats that we've got today and actually be able to use them in the future? So I think that's another challenge. Do we have to store the data and the application together so that the means of opening it is actually embedded with the data? Perhaps that's an approach. I think a better approach for many of these things is to throw them away. You know, we throw away rubbish that's of no use, and the big thing at the moment is that we don't actually put any metric on the data that we store to say what its value is, and the value of data typically diminishes very quickly over time. I mean, I don't remember if this is the exact statistic, but something like after a document's created, 4 weeks after a document's created, the chance of anyone ever looking at it again is, you know, 1%. So 99% of stuff that we produce never gets looked at again after a month. So maybe we really need to rethink the way that we deal with storing data.